Hello, 8th grade algebra. Today we're going to be working with exponential functions. Specifically today, our I can graph exponential functions. You will move on to the second I can in your next video, which is going to deal more with the domain and range and with the asymptotes. But for today, we're just going to concentrate on using a table of values to graph an exponential function. An exponential function is a function in the form y is equal to a times b raised to the x power, where a is a non-zero constant, b is greater than 0 and not equal to 1, and x is a real number. Exponential means you've heard people say, just kind of in life, you probably have heard the expression that it multiplies exponentially, meaning that your rate of change is based on the exponent as well. A real life example might be exponential growth and decay, which we're going to visit in 8.8, which basically means that you are making a profit off of your profit so that it grows exponentially. Another example of exponential might be like a bag of popcorn. It's not linear in nature. It's not like when you put a bag of popcorn into the microwave that it pops 3 kernels per minute or something like that. You know that it starts and it pops and it pops and it pops and then it completely just kind of takes off. So that would be a real life example of exponential in the real world. To evaluate an exponential function, we are simply going to substitute in the value of in this case, x, that's our exponent, for whatever is given. So it's very simple to simplify. We're just going to simply substitute in the 2 for x. Whoopsie. It's simple when my template doesn't move around. Here we go. Finally. And it says, we know that order of operations tells us to do our exponent first. So now we end up with 17 times 9, which is what, 153. For our second example, check right here. I think that yours actually has a number. So just kind of make that an x. So it's saying y is equal to 7/3 raised to the x power. So we're just going to substitute in the -2 for our exponent. And we learned in our last target that when we have a negative exponent outside of the parentheses, that we can just write the reciprocal and then raise that to the positive exponent. So the -2 became a +2, and then we just wrote the reciprocal of 7/3. So y now is equal to 3 raised to the second power and 7 raised to the second power, or 9/49. Final answer. So that's how to evaluate an exponential function. Here are the graphs of an exponential function. Here are 2 graphs that show what exponential functions generally look like. So I want you to pay attention to what's happening with these graphs. We know that a linear equation is just a line. We know right now that a parabola or a quadratic looks like a U. Well, an exponential function is kind of a curve. And so we see in this example, we see a positive exponent and positive coefficient. It is above the x-axis, where, notice this is a negative, we are, you may have guessed it, below the x-axis. And again, notice the shape of the graph. You can look and see the same thing here. We've got a positive, and then over here we've got a negative. So that just gives you an idea of what your graph is going to look like. Evaluate y is equal to 4 raised to the x power for each exponential function for the domain -2, 0, and 3. So in this case, our domain was given. So we simply substitute in 4 raised to the x power. So that's going to be 4 raised to the -2nd power, 4 raised to the 0 power, and 4 raised to the 3rd power. 4 raised to the -2nd power we know means 1 over 4 raised to the 2nd power. Aren't we glad we already know how to do that? So this is listed as an ordered pair, so I'm going to write 1/16. Whoops. Should have listed my x first, so I'm going to list my -2, and then that makes my output or range my y, which would be 1/16. So there's my ordered pair. Then x is 0, And we know that any number raised to the 0 power is 1. And then last but not least, I've got 4 to the 3rd power, which is 4 times 4 times 4, or 64. So this ordered pair then would be 3, 64. And so we could plot those points on a coordinate plane. We're not going to do that for this one though, but this tells you how to evaluate. Our next example, evaluate and graph the function of x is equal to 3 times 2 raised to the x power, where 3 is a, 2 is b, raised to the x. So that's the original function. And I'm going to put a few more points in here so we can see -2, -1, 0, 1, and 2 I'm going to use for my domain. And then I just want to substitute in. So I'm going to do So I want you to pause the video and just do some evaluation to make sure that you can do that on your own. Once you have evaluated your y, then you can just write it in here, and then you can start the video again. So please pause the video, do your evaluation, make sure that you know how to find your output or your range or your y, and then start it up when you are finished. Welcome back. So with your evaluations, then you should have ended up with the ordered pair -2, 3/4 here, -1, 1.5 here, 0, 3, 1, 6, and last but not least, 2, 12. How'd you do? I hope well. So those are the ordered pairs for this particular function. Now, once we've seen the table, then you're going to come over here and you're going to graph the points. I want you to graph the points, and I know that it's not going to be easy because you're talking about very small fractions between integers, but I know you can do it. Once again, once you have finished that, then I want you to stop, and I want you to, or go ahead and start the video up and check your work. This is what your table of values and the graph should look like. Notice the shape of the graph. You'll notice that the graph kind of hugs the x-axis, so it's going to go up here. This is pretty self-explanatory, but then notice here it's not ever going to be negative. So you'll learn more about that when we talk about asymptotes. So you know where the graph should go and if it is going to go below the x-axis. All right, and so here is a real world example. Many photocopiers allow you to choose how large you want an image to be. The function is equal to 1.5 raised to the x power, models the new size of an image being copied over and over at 150%. So you can imagine if you were going to graph and you're multiplying by 150%, obviously the image is going to get larger and larger each time. It's exponential. So here is our domain. The 1, 2, 3, 4, and 5, and you can see that substituted into the equation. So here you have your value of x, and here you have your function of x, or y, which is your output, and that pattern continues throughout the table. And then here are the points. So this is just plotting the points. I wanted you guys to see this. And then if I was to draw in my line, then it would go here. And once again, I know that it's never going to go below the x-axis. Notice the shape of the line and that it is a positive curve going up. Look at the next example. It says you can also make images that are smaller than the original on a photocopier. And this time, look at the function. It's 0.9x, which 0.9 is going to be 90%. So You may have guessed it, 90% means that the photo is going to be just getting a little bit smaller each time. So I wonder what the graph is going to look like. This one is obviously going up. Let's look. I'm just going to put this on a graphing calculator so we can see that. And then look, it's just a gradual decrease of the size of the photo when it's 90%. Notice again the shape of your graph. That is going to do it today for us for exponential functions. I hope that you enjoyed your lesson.